Hi guys, today we are going to start with the third unit. The first topic of the third unit is about temperature measurement and the material I have taken from IIT Kharagpur. So how we can measure a temperature for a particular device. Temperature measurement is very important, and here we are going to looking into the various different types of temperature measurement devices, as well as we are just going to see about the RTD, that is resistance temperature detector. So how this temperature came? In olden days, like 17th century, they are called temper, and it is nothing but used to describe the quality of steel. After the invention of thermometer, the word temperature was coined to describe how much amount of the hardness or coolness of a material body. This is how the temperature word comes. It was the beginning of the 17th century. And the principle is very simple. They are just having a bulb containing air with a long vertical tube. It was inverted and dipped into the basin of water, or it is a colored liquid. So whenever there is a temperature of the bulb and the gas inside, whether it is getting expanded or contracted. So this is the basic one we all know. If there is a change in temperature, then automatically whatever the gas inside the tube, that will get expand or it will get contracted. So what will happen? Automatically there will be a change in level of the liquid will change. So that was happening inside the vertical tube. So there is a major drawback of this instrument, that is nothing but it is not only sensitive with the temperature, but also it is sensitive to atmospheric pressure variation. So after that, there are so many developments have been made for measuring this temperature. There comes the development of the devices like liquid thermometer, RTD, thermocouple, thermistor, AD590, pyrometer. So these are all the devices are used for measuring temperature. So the first one is about the liquid thermometer. It was developed, and the importance is there are two reference fixed temperature with some temperature scaling over there. So they used to calculate the boiling point of the water as well as the melting point of the ice. That was the reference they have made in olden days. So they are just calculating in terms of Fahrenheit. So the temperature of the ice is 0 degree, and the temperature of the human body, we all know in terms of Fahrenheit, is about 96 degree. Then after that they have just calculated with the degree Celsius, then it comes into Kelvin. So for Kelvin scale, the absolute temperature of the gas, which was like 0 degree, and the freezing point, which is 273. So the purpose of the early thermometer was to measure the variation of atmospheric or body temperature. Then after that, so many science and technology advancement, they have a temperature measurement devices for a wide range of different atmospheric conditions with a high accuracy and precision. Because there are so many devices used for measuring the temperature, but it is not giving a high precision as well as high accuracy. So there are so many different types came, that is liquid and gas thermometer, then bimetallic strip, then RTD, that is resistance temperature detector, or it is called resistant thermometer, then thermocouple, then radiation pyrometer. So what is this resistance thermometer? Resistance thermometer, it is also called as an PTC. PTC, which is nothing but positive temperature coefficient. That means your temperature as well as the resistance of a particular wire will directly proportional. That is the reason why this is called positive temperature coefficient. So the resistance of the metallic conductor increases with temperature. That is the reason your RTD will give you the response of linear scale. And here the material they are using like platinum, copper, nickel. and they used to call PT 100, PT 500, PT 1000. What is it PT 100 we used to call? PT is in platinum and 100, which is nothing but the resistance value. So at 0 degree centigrade, your platinum, the resistance value is 100. If the same thing we used to call PT 1000, that means at 0 degree centigrade, platinum will give you the value of resistance is 1000. So we used to call PT 1000. If it is 500 ohm, then it is PT 500. So how could identify? If the same metallic conductor, if you are replacing with a semiconductor, if there is a change in temperature, then it comes under thermistor. The variation of resistance of metals with temperature, which is in the form of RT, which is equal to R naught of 1 plus alpha of T minus T naught plus beta of T minus T naught the whole square. What is that alpha and beta? They are the constant. They are represented with metal. And RT, which is nothing but total resistance. R naught, which is nothing but the initial temperature, that is T naught degree centigrade. What is the initial resistance? So finally that RT, which is R naught of 1 plus alpha of T minus T naught. So alpha, if you are using the material is copper, then the temperature coefficient value is 0.00427 degrees centigrade. And the same, instead of copper, we can use nickel as well as platinum also. So it depends on the material. The temperature coefficient of the value will get varied. And moreover, copper and nickel, they are 120 degree as well as 300 degree respectively. You can just look at the graph over here. There is a relationship between your temperature and the resistance. So we are getting a linear relation for platinum. Then copper, it is just like it is going on increasing. And for nickel, it is also half the way. It is non-linear. From here to here, it is linear. So just you can compare nickel, copper and platinum. The platinum one is pakka. So that is the reason they have used platinum material, because of getting the linear relationship. So what was the construction? So construction point of view, when you are using as an industrial, we can't use acid light because there will be an hazards. So what they are supposed to do is they have to protect against the mechanical hazard. For maintenance is very, very important, and it should be kept inside the well and the resistance material. And not only that, it should be carefully bound over mica sheet so that no strain developed across that particular wire. So this is what the construction part. We have in resistance wire, we have in mica, then ceramic powder and the stainless steel. So this is how the construction of your RTD is made up of. But how we can measure the resistance? We have to go for Wheatstone bridge. Already in the previous class, we had a discussion on Wheatstone. So the unknown, which is the unknown value, in that part we have to connect your RTD. Not only that, we can go for volt ampere method also. You can just look at the diagram. There are two combination, and this is called 3-wire RTD and this is 4-wire RTD. So here these two resistance arms are known. This is variable and the unknown part. The unknown part we are just connected with an RTD because we are going to identify the resistance of this particular wire. So across that we are having the meter. So if there is a balance, then this meter will show 0. If there is a deflection, then automatically we can able to identify the resistance using this Wheatstone bridge. The same way you can go for this 4-wire. This is the resistance lead. Across this B and C we have an voltmeter, and AD we have a supply. So this is what the 4-wire RTD measurement. So using those two combination we can able to measure the resistance value. So this is how your RTD is working. So just I would like to show you how the RTD looks when it is used in industrial point of view and how the construction should be. So I will just show you the video how it looks. Just you can look at here. These are the various different types of RTD. The first one is industrial, then autoclave, transition, plug and play and bearing temperature. So the industrial RTD one, which is used in the industrial point of view. So industrial point of view, RTD, it is like, you can just look at the diagram. This is how they are using. And for this particular industrial one, which has been used for the measurement of the temperature up to 600 degrees centigrade. And the reference standard, they have used IEC. And organization, American Scientific, British Standard, then International Electrochemical, US Department. These are the standards they are using. And the alpha value we have, then the nominal resistance. How the nominal resistance of that particular material used one. And here you can just look at, there is a sensing element. This is the tip point, and this is what the tube, and you have a fitting, and here you have a connecting thread, connecting head. So this is how your RTD looks, and inside the RTD, this is how the construction also. And the reference standard, we have IEC 751. That is what I told you already, PT 100, PT 500, PT 1000. 100, 500, thousands are, it's like in the value of resistance, and the accuracy either it will be in A or B, and the wire configuration is 2 wire, 4 wire as well as 3 wire, and it has 2 leads there. The first lead is white and the another one is red color. So that is 2 wire. Then for 3 wire combination, that is 1 white color and 2 red color. Then for 4 wire configuration of your RTD, 2 white and 2 red. So this is how the connections will be there. So how they are connecting the RTD with the bridge circuit is, before the one, I think you would have understand. Then sheath diameter, that is nothing but from the RTD construction, the outer part, that is what your sheath diameter as well as the sheath length. And the enclosure, which is nothing but the outer part, which one we are going to use it with your RTD. As well as the enclosure, it is very important, otherwise that will be a problem of hazards. So the enclosure, what material we are using, then what type of weatherproof or flame proof we are using, and not only that, the enclosure material we are using. So actually this material I have taken from Engineers Academy. Okay, if you want, you can just look at this. And moreover, this is this particular, so this is how the construction you can look at here. The resistance wire, here we have a 3 wire configuration, or we can go for 2 wire, or we can go for 4 wire configuration. Then here we have an powder, ceramic powder, and here only you have a bulb, the tip point, and the bulb, which is the one, the material either copper, nickel or platinum. Mainly they are focusing on platinum because of because to get a high accurate value. So this is how the RTD construction. Then RTD, how many combinations. Then how that RTD we used to call it as an PTC. I think you would have understand out of this particular explanation, right? Okay, thank you.